Hello everyone, welcome to another ConceptoCAD video. In previous video, we have gone through various commands in the surface toolbar except the sweep command. I didn't explain sweep command in that video because it would have been a very lengthy video. That's why we are explaining the sweep command in today's video. So today's video will be all about various types of sweep, and also one more sweep is the adaptive sweep. So we will go through them one by one. So to do that, I have already created a part in which I have created basic elements which will be used to explain the various type of sweeps to you. So let's get started with it. So I will just launch CATIA and I will open up that part. It's already open. As you can see, I have created various geometrical sets over here depending upon the types of the sweep. This file will be available in the description box below so that you can download it and practice the sweep, all the types of sweep by yourself. So to go to sweep, we will have to go to surfaces toolbar. This is the sweep icon. So here you can select the sweep. As you can see, there are four main types of sweep. These are explicit, line, circle and conic. So we will go through them one by one. The first one is the explicit type. In that there are plenty of subtypes. There are three subtypes for the first explicit type of sweep. First one is the reference surface, second is with two guide curves, and third one is the with pulling direction. So I have created geometrical sets according to them. So I will show you. So to explain explicit type of sweep, I have created a geometrical set for explicit type of sweep. In that I have created various geometrical sets depending upon the types of the sweep. So we will go through the first type of sweep, that is with reference surface. So to do that, I will just define this geometrical set I have created, which contains the basic elements for the sweep with reference surface. I will just define it. As you can see, I have created some basic profiles. So this is my main profile and these two are my guide curves. So I'll click on sweep. In that, in explicit, we will select with reference surface. So for reference surface of type of sweep, we will require two inputs. The first one is the profile and second one is the guide curve. So I will select this as my profile and this will be my guide curve, and I will just click on preview. As you can see, this profile is following this guide curve and a surface is created in that direction. That's the meaning of sweep. Actually, sweep means if you are taking any profile and you are making it flow along a guide curve, the surface which is generated is called as the swept surface. So as you can see here, a swept surface is created in according to this guide curve. So now I don't want this as my guide curve, I will select another guide curve. So just click over here, select another guide curve, click on preview. As you can see, this profile is now flowing in the direction of the second guide curve. So this is the first type of sweep. It is used plenty of times, it is very useful. Now we will see the second type of explicit type of sweep. Second is with two guide curves. Like we selected only single guide curve in case of the with reference, we will select two guide curves for the with two guide curves type of sweep. So I will just click OK and I will delete this sweep. Okay, so we will just create another type of sweep. So I will select with two guide curves. I will select this one as my profile and this is my first guide curve. This is my second guide curve. So click on preview. As you can see, this profile is following both the guide curves for now, and it will maintain the normal to this profile to the guide curve. So click on preview and click OK. So as you can see, a swept surface is created by using a profile and two guide curves. So this is the second type of sweep in the explicit type. So to explain the next type of sweep, I will just quickly hide this one and define the geometrical set of next type of sweep. So next one is the sweep with pulling direction. Select sweep with pulling direction. Now you will select this as my profile and this is my guide curve. I just want this profile to be rotated around the circumference of this circle, and I will select a direction from which I will maintain an angle of this profile. So I will select Z as my direction, click on preview. As you can see, a swept surface is created along the periphery of the circle, and a 14 degrees angle, which is mentioned over here, is applied to that profile. So as you can see, this surface is at 14 degrees to the z-axis. So click on preview and click OK. So this is sweep with the pulling direction. One more thing remain to explain in this is the relimiter 1 and relimiter 2. So as the name suggests, relimiter limits the extremities of your swept surface. So I want to limit this sweep to this plane only. So it is a YZ plane. So I will click on relimiter 1, right click over here, and I will click on YZ plane and click on preview. As you can see, the swept surface is now limited to only YZ plane. So if you want to create a relimiter anywhere on the curve, you can create it by creating a point and creating a plane on that point. So second relimiter you can also define. So click on right click in this relimiter 2 and select XZ plane. Click on preview. So as you can see, the swept surface is now relimited in both the directions by using YZ plane and by using ZX plane. So this is all about sweep with pulling direction and relimiting the sweep. One more thing here you can see is angular correction and deviation from the guide. So what angular correction do is, it is a parameter related to the angular tolerance of the moving frame, and the deviation means the gap authorized. So in the case when you receive a very bad base surface, by bad base surface I mean a surface having a lot of minor gaps, then you have to adjust these parameters to get a smooth surface. So now these parameters vary from company to company, so you don't have to worry about it, and mainly it's used to join two surfaces within a tolerance limit. So you will see these two options in almost in every command where you have to create a new surface using a blend, multi-section or sweep. So you have to adjust this value so that your gaps will be get closed and you will get a smooth surface. So now we will move on to the next type of sweep. I will just go click on preview, click OK. So the next type of sweep is, in the main type is line, and in that two limits. So I will just hide this geometrical set and I will define two limit geometrical set in line type of sweep. So I will just define it. So yeah, as you can see, I have created two profiles or two lines using the offset plane from this base plane. I have offsetted a plane from this plane at 100 mm on the either side, and I have created these two different sketch. So and always remember that you cannot draw a profile or a guide curve in the same sketch. If you want to draw the guide curve in the same sketch, you are not able to do that, because every guide curve is considered as a separate entity while doing the sweeps. So you have to remember that you have to create your guide curves in entirely different sketches. One sketch, one guide curve only. So I'll just click on two limits. So it is asking for guide curve 1 and guide curve 2. As the name suggests, it creates a sweep between the two guide curves. So I will select this one as my guide curve first and this one as my guide curve second and click on preview. As you can see, a swept surface is created between these two guide curves. Also here is an option of relimiter, as I explained to you, and one more option is there is length 1 and length 2. If you want to extend your surface uh, ahead of the guide curve, so you can increase these values in either direction. Like I will do this as 50 and I will do the length 2 as 50 as well and click on preview. As you can see, the surface is extending 50 mm on the both sides of the guide curves. So this is basically sweep of two limits. So click on OK. It will be create a sweep surface. So next one, go hide this one and define this one. Next one is same as this sweep with two limits. So I will just click on next one. So next one is the limit and middle. So I will select guide curve 1 and guide curve 2, click on preview. What it does is, it is same as the sweep with two limits. As we were giving the values to extend the surface from the guide curves in the two limits type of sweep, here that's not the case. It will treat the second guide curve as your middle of the sweep. So here, as you can see, if I will click on preview, it has created a swept surface with the second guide curves as its center portion. So this is the sweep with limit and middle. So to explain next type of sweep, I will hide this one and I will define with this one. Okay, so click on sweep. The next type of sweep is very important. It is with the reference surface. So this will ask for a guide curve and a reference surface. So as you can see, the third input it's asking is the angle. So right now I want to create a vertical surface from this edge of the surface at 90 degrees. So I will just provide this angle to be 90 degrees and click on preview. As you can see, a swept surface is created which is at 90 degrees to the base surface and it's extending on either sides. So if you want to change this value, if you want this swept to be performed only on one side, you just have to change the value on the another side to 0 and click on preview and click OK. As you can see, swept surface is created at the 90 degrees to the base surface. If you want to change the angle, just double click on the sweep and I just want it at 45 degrees. So I will just change the value to 45 degrees and as you can see, it got updated. So this is a very useful type of sweep. You have to practice it with various types of surfaces and conditions so that you will get better at it. So next type of sweep is with reference curve. As this was with reference surface, it's with reference curve. So I will quickly hide this one and I will define this one. So I have created a reference curve and a reference surface over here. So just go to sweep, select with reference curve and I will select this as my guide curve and this is my reference curve. And I will define this angle as 180 so that I can show you that how it follows that curve. So as you can see, I use this as my guide curve and this is my reference curve. So what this sweep do is, this reference curve as it flows towards this reference curve, it will adapt the shape of this reference curve. I'll just show you. Right now the value is 50. If I extend it to 100 mm, click on preview and click OK. As you can see, my base profile was this, but my reference profile was this. So when I swept it from this position to this position, the surface changed its shape and adapted to the shape of this reference curve. So this is basically a sweep with a reference curve. So if you want to your surface to adapt to a shape of any reference curve, you can use this one. Now we will move on to the next type of sweep, that is sweep with the tangency surface. So I will quickly hide this one and I will define this one. So to get a sweep with tangency surface, we will require a surface which with we can define a tangency. So I will just select it, select the subtype as tangency surface. So the two inputs are required in this one. One is the tangency surface and second is the guide curve. So I will just select guide curve and click on tangency surface. So a surface will be created which is tangent to this profile and up to this guide curve. So click on preview and click OK. As you can see, a surface is created tangent to this semicircular surface and it's limited to the guide curve. This is also a very useful type of sweep. So we will see next type of sweep. The next one is very important as you will use it plenty of times when you are doing surface designing using main tooling direction for your draft and all. So I will just explain it to you. So I will hide this one and define this one. So as you can see, I have created two things over here. The first one is a curve, guide curve, and second one is the main tooling direction of my tool. So what is mean by main tooling direction? So while creating any plastic product, you have to consider the tooling direction of your core and cavity. So core and cavity, all these things will be explained in a separate playlist in the plastic product design, which is I'm going to start in the next week. But you can just imagine that your plastic part is going to be ejected in this direction. So while designing a plastic part, a draft is given on every face with respect to this main tooling direction. So this type of sweep does only that. So I'll just show it to you. So select as with draft direction, select the guide curve, and draft direction will be always your main tooling direction, which is shown in the yellow dotted line over here. So I'll click on this one, and here you can specify the angle. Normally draft is given more than 0.5 mm and so on, so it should be always more than 0.5 degrees. So I'll just give the value to be 15 degrees and click on preview. As you can see, a swept surface is generated using this curve and at a 15 degrees angle to this main tooling direction line. Here you can see it is defined as a draft direction, and also there are various zones of this or angular sectors of this sweep, as 15 degrees angle can be in this direction or this direction or this direction. So you can change that angular sector by selecting these arrows and click on preview, or either you can change it over here using this one. As you will click on next, it will change the direction and it will be highlighted over here. So click on preview and click OK. So as you can see, a swept surface is created at an angle of 15 degrees to main tooling direction. You don't have to worry about the main tooling direction and all those things. I will cover those up in the plastic product design playlist. So moving on to the next type of sweep, that is sweep with two tangency surfaces. So we will define this one and hide this one. So as we have created a sweep with one tangency surface and one guide curve, this will create a sweep surface between the two tangent surfaces. So we will select with two tangency surfaces. It will ask for a spline. The spline is basically a direction in which you want to create your sweep. So I will select the direction as x-axis and then select the first tangency surface and select the second tangency surface. Click on preview. As you can see, a swept surface is created between the two profiles and tangent to both of the profiles in x direction, as well as you can select it in the z direction or y direction. So this is all about line type of sweep. So I will just minimize this geometrical set and we will move on to the next type of sweep, that is circular type of sweep. We'll hide this one. So the first one in the circular type of sweep is with three guides. So as the name suggests, you have to select first guide curve, then second guide curve and the third guide curve and click on preview. Click OK. As you can see, a circular profile is created using the three guides and it is tangent to those guides at all the points. So this is used to generate circular profiles using the sections or the guide curves. The second type of sweep in the circle type of sweep is sweep with two guides and radius. So we will hide this, define this, click over here, select with two guides and radius. I'll select this as my first guide, this as my second guide, and I will specify a radius. So if click on preview, as you can see, there are two possible circular profiles or circles through these two guides having the radius of 80 mm. So whichever profile you want to keep, you just have to click on that profile and click OK. As you can see, a circle of radius 80 which is passing through these two guides is created as a swept surface. So if I want to keep this as my desired circle, I'll just click on it and click OK. So this is with the two guides and radius. Now the third one is sweep with center two angles. Let's quickly define this and hide this one. Okay, so this requires two inputs, one your center curve and other the curve at the value of your radius. So I have just created another curve over here by taking an offset to this plane at a value of 100 mm, and I have just created another curve. So I'll just go over here, I'll select center and two angles. It will require two inputs, as I told you. This one is my center curve and this one is my reference curve, and here are the value of the angles. So as I will click on preview, you can see that a circular or a segment of a circular portion is created at a radius of the distance between these two curves, and which is limited to an angle of 45 degrees. Now I want it to be limited to 90 degree, so I'll just change the value over here and click on preview. As you can see, a segment or a quarter circle cylindrical profile is formed over here. So it is basically used to create a cylindrical profile which is to be limited by certain angles. Remember here that the value of radius is the distance between your two curves, whichever you specify when you are offsetting this plane from the center plane. So click on preview and click OK. So the next type of sweep is with center and radius. So we will define this and hide this one. Okay, so this requires only two inputs, one center curve which I have created over here and radius. So click over here, select center and radius. I will select this as my center curve and here specify the radius that you want. So click on preview. As you can see, a cylinder is created using this curve as the center and 100 mm as the diameter of this cylinder. So this is the sweep with center and radius. The next one is sweep with two guide curves and tangency surface. I'll just define this. Okay, this is a interesting type of sweep. If I want to create a sweep which is tangent to this profile and it should be limited to this guide curve, we use this type of sweep. So I'll just click on sweep, select two guides and tangency surfaces. First one is the limit curve with tangency. What is the limit curve with tangency is, it's a curve which is present on the tangency surface and from where you want to start your new swept surface which is tangent to this tangency profile. So I'll just click on this limit curve. Second, I will select the tangency surface, and next one is the limit curve and click on preview. As you can see, a tangency surface is created over here in this direction. If you want to select the upper portion of the tangency surface, as at this position the tangency can be created in this position or this position, that's why it's showing two options. So whichever you want to keep, you just have to click on it and click OK. As you can see, a swept surface is created which is tangent to this surface from this curve and which is limited to this guide curve. So this is basically sweep with two guide curves and tangency surfaces. Moving on to the next, which is one guide curve and tangency surface. So I will hide this, we'll define this. So as the name suggests, it will create a tangency swept surface. So I will select one guide curve and tangency surface. So I will select this as my guide curve, this as my tangency surface, and I will define this radius to be 100 mm. Click on preview. As you can see, a tangent surface to this surface is created, which is limited to the reference curve, and this surface is having the radius of 100 mm, which we have specified over here. So these all types of sweep are basically for creating a circular section or a section limited to certain angles of a circular section. So click on OK. So as you can see, a tangent surface is formed over here. Now the next one is very useful, which is sweep with limit, curve and tangency surface. So I will hide this one and I will define this one. Okay, so go to the sweep command, select limit, curve and tangency surface. So as I told you, this will be my limit curve, which is on the tangency surface, and the surface ends at that curve. That's why it's called as limit curve. And this one is my tangency surface. So click on preview. As you can see, I have provided the radius to be 100 mm. So at this point or at this edge, tangency for the new surface is possible in two directions, like this one or this one. Whichever you want to keep, you just have to click on that side and click preview and click OK. As you can see, a tangency surface is generated over here. So I want to keep this one and just click on that, select this. So this surface is tangent to this surface at this limit curve. So this is basically all the types in the circle type of sweep. So we will move on to the next type of sweep, which is conic. I will just hide all this. Next I will expand the conic type of sweep. So I will just go for the first type of sweep in the conic. So click on this, select conic, and first one is the two guide curves. So this type of sweep creates a somewhat tangent swept surface between these two guide curves. So this will be the first guide curve, and the plane on which this profile is lying will be my tangency surface. Here you can create a surface, or a plane is also considered as a surface. And next one is the last guide curve and tangency surface, and here is the angle. So I'll just provide this angle to be 15 degrees. Click on preview. As you can see, a swept surface is formed over here between these two guide curves, and this surface is at 15 degrees angle from this plane, which is my tangency plane, and it's extended up to this profile. So click on preview, click OK. As you can see, a swept surface is generated. These type of sweeps are not used that much, so you don't have to worry about the details of it. So next one is the sweep with three guides. So I will hide this and define this. So we will just go into it, select three guide curves. So first guide curve, and again the tangency is the plane. Then second guide curve needs no tangency, and the last guide curve and the plane of tangency, and here is the angle, or you can provide an angle over here. So click on preview. As you can see, it has created a swept surface from these three guide curves, and it is at a 15 degrees angle from the first tangency plane, and it is going through this curve and it's ending over this curve. Here you can also specify an angle at which you want it to be oriented. So click on preview and click OK. It's just used to generate a semicircular or arc like profile. So next one is with the 4 guide curve. This one is interesting, so I will hide this and define this one. As you can see, I have created a base surface from which I want to create a surface extending through these curves using the 4 curves. So I'll just go over here, select 4 guide curves. So first one will be my guide curve, and I want the generated swept surface to be tangent to this existing surface. So I will just click on tangency here and select the second guide curve, third guide curve, and fourth guide curve. So click on preview and click OK. As you can see, a new swept surface is generated which is tangent to this surface and going through the second guide curve, third guide curve, and fourth guide curve. So it is basically used to extend or create a swept surface using the 4 sections through which you want your swept surface to go. So this is the sweep with 4 guide curves. Similar to that, there is a sweep with 5 guide curves. So we will quickly hide this and go into this. So I have created 5 different curves on different planes over here, as you can see. So we will see what is a sweep with 5 guide curves is. So I will just select various guide curves that I have created. Okay, these are just lines which are lying on the different planes. Actually it seems difficult, but it's not. So click on preview and click OK. So as you can see, a swept surface is formed which is going through all the lines that I have created. I have just offsetted these planes by same value like 100 mm or 200 mm, and I have created a line which is at some distance from the previous line. So this is the first line, this is the second, this is the third, fourth, and fifth. So this is basically the conic type of sweep. So these are all the types of sweep, which are almost, I suppose, 21 types altogether. The next type of sweep is an interesting one, which is adaptive sweep. This command is not listed under the sweep command, it's given as a separate command. It's the adaptive sweep over here. So I will just go ahead and define the geometrical set of adaptive sweep. So to make you understand, I have created a base surface and a section over here. So adaptive sweep creates a swept surface based on the sections along the guide curve and the constants that can be specified for each of this section. What I mean by this is, adaptive sweep allows me to change the shape and size of this section at various points along the guide curve. These points will be predefined. So as you can see, I have created 2 points. One is over here and second is over here. So I will show you how a adaptive sweep is created. So go ahead, click on adaptive sweep. First input is the guide curve and second input is the section. Click on S. So as you can see, if I click on preview, a normal sweep is created using this section and along this curve. So if I want to change the shape and size of this section at this particular point, so I will just go ahead and click on this point. So here, as I click on this point, you can see that the base geometry and its dimensions appear over here. So if I want to change a particular dimension, like I want to change this radius from 30 to 50, so I can change that. And again, if I want to change any length or any angle of that particular profile, I can change it over here. So what it do is, it gives us the control to maintain or to change the cross section of the profile at any particular point. So I'll just click on preview and click OK. So as you can see, at first we were having a radius of 30 over here, but I have changed the radius to 50 mm over here. So you can see a very smooth transition from 30 mm radius to the 50 mm radius. So we will go ahead and create another section at another point. So I will just select this point. Again, you can see the base sketch is appearing over here. So I want this radius to be 100 mm now. As you can see, I have changed, so it is a very large value, so I will just keep it to 75 mm. Okay, as you can see, the radius over here is changed, and I will keep everything else as the same. So I'll just click on preview and click OK. As you can see, the radius which was 30 mm over here, it's changed to 80 or 75 mm over here and over here also. So you will see a very smooth transition. So by using adaptive sweep, we can modify or change the dimensions of the section at multiple points which are lying on the guide curves. As the section adapts to the changes in the section at different points, it is called as an adaptive sweep. So this is all about adaptive sweep. One more thing to notice in the adaptive sweep is, if I click on this, the parameters related to the sketch can be changed directly from here by double clicking on it, or just select the section and go over here in the parameters. So it will show the basic parameters which are defining your sketch, like my 70 degrees angle which is over here, it's being shown over here, then the 85 mm height of the feature and the 75 mm radius. So I can vary those value over here also and click on preview. So this is basically used to control values of the dimensions at a particular section. I can change the values for the different sections by selecting here. So I want to change the dimensions of first section or the second section. I just have to go over here from the drop down menu and select and click on these values to change them. So we'll go back to sections. So I will create another section over here at the end point. So I will not change the dimensions for that. So I will just click on this point, and again one more section at this end point, and click on preview, click OK. As you can see, my section is changing its shape at a predefined point, like over here, and at endpoints I have kept the profile as the base profile. So this is basically adaptive sweep. So I hope you understood all the type of sweeps which are present in CATIA. Sweep is a very powerful command, and it's used plenty of times to generate a surface where multi-section or blend cannot do the same. So you have to go through each and every command of sweep. I'm just attaching this file which I have created by the name of sweep commands explained in the description box below, so that you can download the file and you can try various type of sweeps that I have created while demonstrating the types of sweep to you. So you just go through it, create all the type of sweeps and do practice on it a lot, so it will be useful for you in the future. So that's all for today. If you like my work, do subscribe my channel and stay tuned to get more tutorials on the generative shape design. Thank you. So keep spreading the word and have a good one.